All right, today we're going to start a brand new chapter. It's 5.1 about ratios and ratio tables. If you would, please take out your red pen, and I want you to fill in this top section of your notes for me, please. All right, so the first thing we've done is we've written down the definition of a ratio. A ratio is a comparison of two quantities. Quantities is just a very fancy way of saying two numbers, okay? So we're going to be comparing two numbers together. Just like we just compared the two girls back there together, ratios are comparing two quantities or two numbers. There are three different ways to write a ratio. The first one right here, what's it say? A to B. The next one has this little semicolon right there, but you would also read it A to B. A lot of times we would look at this and say, oh, that's A over B. But guess how we would read that as a ratio? A to B, okay? So we're going to be reading these the same no matter what. There's just three separate ways that I'm showing you. You can write a ratio. Read to me this last thing that you wrote in red pen. A ratio is basically dividing the first quantity by the second quantity, okay? So you're dividing one number by another number. That's the basics of what ratios are. So today I am going to show you, here's a little recipe for making flubber. Does anyone know what flubber is? Luke, what is it?
It's almost like a rubber, but it like floats.
A kind of rubber that floats. That's a very interesting description, okay? It's kind of like slime. Has anyone in here ever made slime before? All right, but as he said, this is like a rubber that floats, called flubber, okay? Floating rubber, I like that. So here's the recipe for it. How much cold water do I need to make this flubber? 3/2 of a cup. How much hot water do I need? 4/3 of a cup. How much glue do I need? 2 cups. And how much borax do I need? 3 teaspoons. Now, as you can see up here, what two things am I comparing today? Okay, when I ask you for ratios, I'm only going to compare two quantities or two things. So in this case right now, I don't really care about the hot water and I don't really care about the borax, all right? You don't have to cross it out, but just know those parts right now are not important. We are just focusing on the cold water and the glue, all right? So it asks us to write a ratio. Remember, a ratio is comparing the two. How much cold water does it say that I need, class? 3/2. Everybody write 3/2. And the first way that I told you that you could write it is with the word 2. And how much glue did we have? 2 cups. 3/2 to 2. That is one way that you could write a ratio. Just for our notes in this first example, we're actually going to write all three ways. The next one in your notes had a little semicolon there. 3/2 to 2. Box that part in. Did anyone catch what the last way was that I can compare two quantities? Jacoby, what would it be?
3 and 2. 3 and 2.
We're going to write it just like a fraction, right? So 3/2 over 2. All right, box that in. Those are the three different ways that we can write a ratio. Now, the next thing that it asks me here is the value of the ratio. Our goal is going to be to find a value of the ratio every single time that I give you a table. The value of a ratio basically is how to compare the first amount to the second amount. All right, so when we do this, we're going to always use this method over here of dividing. So I want you guys to write, you're going to have to write kind of tiny. I want you to write 3/2. And when you're writing over, this fraction bar is just going to be a little bigger than the other one, 3/2 over 2, because that can be confusing having a fraction inside of a fraction, okay? So then just give yourself a little arrow, basically to tell us this means 3/2 divided by 2. Now I want to turn that 2 into a fraction so I can put it over the number 1. Very good. Am I ever allowed to divide fractions? No. So what method do I have to use? KFC. Everyone take your red pen and I want you to write KFC. Just to remind yourself you are not allowed to divide fractions, so we will use the KFC method. The KFC method tells me that I'm going to keep the first one, flip the, and then change the. Very good. Jonathan, is there anything that I can cross-reduce? No, there's not. So we're going to multiply it out. And Jonathan, when you do that, what do you get? 3/4. Everyone box it in. That is the value of our ratio. So basically that's helping me to understand how the first quantity compares to the second quantity. Now, we're going to have an interpretation. Interpretation just is, what in the world does that mean? Okay? So let's go back to the basics. What two things am I comparing here? Cold water and glue. So the first thing I want you to write down is the amount of cold water, because that's the first thing that we are comparing. And now I'm going to use the value of the ratio that I found. What number did I get for the value of the ratio? 3/4, okay? So the amount of cold water is 3/4 the amount of, and what was the second object that I am comparing it to? Glue. So that's what that whole entire thing means. The amount of cold water is 3/4 the amount of glue. If you would, I want you to pull out your red pen and fill this in. Today we're going to be talking about equivalent ratios. Guys, do you know what equivalent means? Equal, okay? So equal ratios. Here the definition says it's two ratios that describe the same exact kind of relationship. 1/2 is the same thing as 2/4. Can anyone else think of another fraction that also means 1/2? Ellie? 3/6, very good. What's another one? Autumn? 4/8. Who can give me one more fraction that means the same thing? It's equivalent. Jace? 6/12. Very good, okay? As you can see, the top number is exactly half of the bottom number. All of those right there are equal. They are equivalent. So now we're going to talk about some equivalent ratios or some equal ratios. This tells us to find the missing value of the ratio table and then to write what the equivalent ratios would be. This tells us we can organize equivalent ratios inside of a table. If you are ever working from the top of a table to the bottom, I want you guys with your red pen to put a little arrow. So if this case, I'm working from the top to the bottom, every time you're going to divide. So let's just give a guess. On the other side, I want you to put an arrow going from the bottom to the top. What is the opposite of divide, class? Multiply. So if you're ever working from the bottom of the table to the top, you're going to have to multiply. Now, the key always of finding the value of the ratio is this. You're going to take the top number and divide it by the bottom number. So class, if x is 18 and y is 3, what would the value of this be if I divide 18 divided by 3? Class? 6. Okay, so everybody put a 6 right there. This is basically the missing link, all right? You have to find this missing link in order to be able to do any of this. Here's what's cool about a missing link. Once you find the missing link for that first one, you are allowed to stick that missing link all the way across the entire table. It's like the easiest work you can possibly do, okay? In this case, the order matters. Let's focus on this next one right here. Do I know the bottom number or do I know the top number? I know the bottom number. So this right here tells me I am working from the bottom to the top. So what do I have to do? I have to multiply. Guys, what's 5 times 6? 30. So that means if the y is 5, the x is going to be 30. Let's go to the next one. 42. Do I know the top number or do I know the bottom number? Top. So I'm going to work from the top to the bottom. When I'm working from the top to the bottom, what do I have to do? Divide. Just the girls. What is 42 divided by 6? 7. Very good. I want you to do the last one on your own. Please stand once you know the answer. Everyone who's standing, what's the answer? 24. Good job. You guys worked from the bottom to the top and you had to multiply. You guys may have a seat. Now I'm not completely finished because right here it says write the equivalent ratios. So now what we're doing is we are writing what we came up with, okay? So the first one, I want you to put this underneath where we wrote this right here. We're going to write comparison of what the x to the y is. You don't need to cross this out, but at this point, my missing link doesn't need to be there anymore. Once again, I don't want you to cross it out, but just for visualizing. I'm comparing the first thing to the second thing. So I'm going to write it as 18 to 3, okay? Then I'll put a little comma. Let's compare this one. What will I write, class? 30 to 5. Next one, Luke. What will I write? We're comparing the third.
6 to 7.
Not 6 to 7. Remember, pretend that missing the value right there is no longer there. We're comparing the top to the bottom. Very good. 42 to 7. And Regan, what is the last one? Very good. This is our answer, so we're going to box this in. So just remember here, a ratio table is basically a combination of a bunch of equivalent ratios, things that are equal to each other. All right? Let's do another example very similar to this. Take your red pen just to help us remember. If I am working from the top and I know the top and I'm trying to find the bottom, will I divide or multiply? I'm going to divide. Just the opposite on the right-hand side. If I'm working from the bottom to the top, what do I need to do? Multiply. Okay, so in this case, we are going to be comparing cups versus quarts. Remember, in order to find for right here, if you want the ratio table, you want all the units to be the same all the way across. So I am going to work from the top down to the bottom, which means I am going to divide. Very good. So let's take that first one. 3 divided by 3/4. All right, so another way to write that is 3 divided by 3/4. Abigail, what can I put underneath that 3 to make this a fraction? A 1. Abigail, help me to do the next part. What should I do? Am I allowed to divide fractions? Okay, I can only do it if I do KFC. So tell me what to write.
Put 1 over 3.
Nope, keep the first one. Flip the second one.
Flip the second one, which is 4 over 3. And then you cancel both of the 3's.
Okay, both of the 3's get canceled out, and what are you left with?
4.
Just a 4. So that tells me that the value of my ratio is 4. Remember, I'm allowed to put this up into my ratio table. The value is 4, and because the value has to be the same all the way across the entire thing, I'm going to write a 4 in every single blank. Now that I know the value of my ratio, it should be a lot more simple to be able to figure out what the quarts and the cups should be. Let's focus just on this one right here. Jacoby, do I know the top number or do I know the bottom number right now?
You know the top number.
I know the top. So I am working from the top to the bottom. According to this little arrow, what do I have to do when I know the top to the bottom? Divide. What is 12 divided by 4?
3.
Excellent. Put that in. Let's go on to the next one. Autumn, do I know the top or do I know the bottom?
On the top.
I know the top. So I'm working from the top to the bottom. What do I have to do? Divide. Okay, so I'm going to divide what?
15 divided by 4.
15 divided by 4. Guys, do you see what came out right there? A fraction. So here's the deal. If I give you fractions at the beginning of the problem, I want your answers to come out as fractions. Because you can see right here, this is an improper fraction, that gives you permission to be allowed to keep that one as an improper fraction. So 15/4 is the answer. For this next part right here, I know the bottom and I'm working to the top, so should I multiply or divide? I have to multiply. I'm just going to do this over here. Take that bottom one, 5/4 multiplied by 4. Maddie, is there anything that I can cross reduce? Yes. What is it? Okay, so what is my answer? 5 is correct. All right, we're going to put that up here at the top. Now, it has asked us to tell you what the equivalent ratios are. Remember, when putting in equivalent ratios, I don't need the missing link anymore. So I can pretend that this value of the ratio is no longer there, and I am just comparing the cups to the quarts. So looking at the first one, I have 3 cups to 3/4 quarts. Let's go on to the next one. Luke, What's that equivalent ratio? 12 to 3. Okay, so I'm just going to put a comma, 12 to 3. Halen, what will I write for the next one?
15 to 15 over 5.
Excellent. And Jocelyn, what am I writing for the last one? 5 to 5 fourths. All right, that is the equivalent ratios, so go ahead and box that in. All right, for this next example, I am comparing kilometers to hours. Take your red pen. If I am working from the top to the bottom, do I need to divide or multiply?
Divide.
I will divide. If I am working from the bottom to the top, I have to multiply. First things first, we want to find the value of the ratio. In this case, we're going to kind of separate this. If you would, put a little number 1 above the first one, put a number 2 above the second, and a number 3 above the third. We're going to do the work for the first one right here. I'm going to take the first quantity and divide it by the second quantity. Nasir, I am going to go 5 halves divided by 4. All right, so I'm going to have you help me with that one here in just a minute. Basically what that means is 5 halves divided by 4. Nasir, tell me what to do next. KFC, tell me what to do.
And you would keep the 5 over 2 and make the 4 1 over 4. Then you would multiply, so then it would be 5 8.
Very good. 5/8. So that is the value of my ratio. Remember, once you find the value of the ratio for the first one, that is the value of the ratio or the missing link for the entire table. Let's go on to the second one. Who would like to help me find the answer for the second one? If it's 16 hours, I'm wondering how many kilometers it will take me. Jonathan, tell me what to do. Am I going to multiply or divide? Multiply, okay? Because notice it gives me the bottom number and I'm working to find the top number. Okay, so we're going to multiply 16 times 5/8. I could put this as a 16 over 1. Jonathan, keep going. They become 1 and 2. Very good. And what do you get? 10 over 1, which is 10. Excellent. We're going to put that up here. So that means in 16 hours, I'm traveling 10 kilometers. Who would like to do the very last one for me? All right, Halen, go ahead. Am I going to multiply or divide these together? I'm going to divide. Notice, it gives me the top, and I'm working down to the bottom, so that is correct. I'm going to divide 5 divided by 5/8. All right, Halen, what do I do now?
So now we're going to keep the first one.
Very good.
And you're going to flip the second one.
Very good. Then we change the operation. Keep going.
And then you can cross cancel the 2 5. So you would just end up with 8.
You would just end up with 8. That is fantastic. Okay, then I'm going to put that up here in my ratio table. Now, I am comparing, all right? We're going to write equivalent ratios down. So we are comparing this top kilometers to how many hours it takes. So the first one says 5 halves kilometers to 4 hours. Jace, what is the next comparison on the second one right here? Okay, now here's the deal. Remember what I said before. The value of the ratio was a missing link, but when we're writing these equivalent fractions, we're pretending it's not there. You're comparing kilometers to hours. 10 to 16, very good. And the last one, Luke.
3 to 8.
Not 3 to 8, what's
My bad. Oh, 5 to 8.
5 to 8?
I saw that 3.
That's okay. All right, and those are our equivalent ratios. So basically, if I were to interpret this right here, let's say if I am traveling 5 kilometers, it's telling me it's going to take me 8 hours. Let's look at this think pair share. It says, You mix 2/3 teaspoons of baking soda with 3 teaspoons of salt. Write the ratio of baking soda to salt, then you're going to find the value of the ratio, and then we're going to interpret what the value of the ratio means in a complete sentence. So the first thing we're going to do here is write the ratio of these two things. If I write the ratio of these two things, I want us to write it like a fraction bar. So let's just focus on the first thing here, the amount of baking soda that we have. We are comparing the baking soda to the salt. Does anyone know how to do that as a fraction? Jonathan? Okay, 2/3 over 3, all right? So that's comparing the two, 2/3 to 3. We learned a few different ways that we could write that, 2/3 and put the little number 2, okay, or the word 2. But in this case, we're just going to do it like this. Now, let's interpret kind of what this is meaning to find the value of the ratio. I'm going to have 2/3 divided by 3. Reagan, what can I put underneath that 3? A 1. Very good. Okay. Autumn, help me with what to do next. Okay. Keep the first one, flip the second one, and change the operation. Maddie, what should I do next? Okay. Is there anything I can cross cancel? The 3 and 2 do not evenly go into each other, so I cannot cross cancel anything. So instead, I'm just going to multiply across the numerator and multiply across the denominator. Ellie, when I do that, what do I get? 2 over 9, okay? So that is the value of my ratio. Let's put that down here. 2/9 is the value of my ratio. Now it asks me to have you interpret. I want everyone to go back to their notes, and if you would, look at example 1. You could see the interpretation here. We were comparing cold water and glue. It says the amount of cold water is 3/4 the amount of glue. Now we are not comparing cold water and glue. What two things are we comparing? Okay, you're always going to compare the first thing that you see in your problem, baking soda to salt. So I want you guys to use the interpretation that you wrote on problem number 1 and see if you can come up with the interpretation for this think, pair, share problem. All right, was there anyone who came up with an interpretation? Reagan, what'd you get?
I said the amount of baking soda is 2/9 to the amount of salt.
That is perfect. Notice she said the amount of baking soda. That was the first object we have there, okay? So she said the amount of baking soda is, and then she took our value of the ratio, 2/9, the amount of salt, which was the second quantity that we were comparing. Was there anyone else who got the same thing? All right, very good. So anytime, like tonight on your homework, if it asks for an interpretation, go back to this. The amount of the first object is this much, the amount of the second object. Okay, this one says find the missing values in the ratio table and then write the equivalent ratios. If you look at this right here, it is missing something that the other tables had today. Guys, what's this one missing? What did that line, what did that whole box, what was it on all of the other ones? The value of the ratio. Most time if someone teaches you something, they don't have that missing link line. I put that in there because to me, it makes more sense if you have the missing link, okay? But in this case, I think you guys are smart enough to figure out what the missing link is. If you look up here, the calories are 20, the miles are 5. Does anyone know the missing link?
4.
4, how'd you get that?
Because you divided.
You just divided. 20 divided by 5 is 4. Now, remember, the missing link is the same all the way across the board. 4 for everything. So if I were to focus on this, 3 miles, how many calories would that be, guys? 12. How'd you get that?
Because you multiplied.
You multiplied by the imaginary missing link we have in our head. So go ahead and put a 12. The next one, if I have 16 calories, how many miles will it take me? 4. How'd you get that?
Because you divided by 4.
You divided, okay? Once again, tonight's homework is going to look like this. It will not have that missing box, but you can do it in your head or you can write it in there if you want. Final one. This has been the hardest one for everyone today. I'm going from the bottom to the top. What do I have to do?
Multiply.
Multiply. Guys, what's half of 4?
2.
2. So the final thing it wants you to do is to write the equivalent ratios. 20 to 5. What would the next one be? 12 to 3. What's the next one? 16 to 4. And the final one. 2 to 1/2. All right, so that is how you have equivalent ratios. All right, so tonight your homework is 7 problems on big ideas over 5.1.